All right, now this next part of this next part of lesson 3.4 starts on page 149, and it basically is talking about how do I multiply a binomial by some polynomial. So here's the deal. Now this is going to work for any size polynomial times any size polynomial. Basically, that distribution rule that we dealt with a monomial times a polynomial is going to work in the same way, except since I have multiple terms over here on the left, here this example 1 says x plus 2 times the quantity x squared minus 4x. Let me pull that one up here. So what you're going to do, since I have two terms here on the left, term 1 is the x, term 2 is the 2, I'm going to take that x and I'm going to multiply that by both terms on the right-hand polynomial. So what I'm effectively doing is I'm taking the x, I'm multiplying that times the x squared, and then I'm also multiplying that x times the minus 4x. Now, after I do that, I'm going to do the same thing with the 2. I'm going to take the 2 and I'm going to multiply that times x squared. And then I'm going to take the 2 and I'm going to multiply that times the minus 4x. So I have this piece multiplied times every term on the right-hand polynomial, and I have the 2 multiplied times every term on the right-hand polynomial. Now notice what that does. That gives me 4 different terms to start out with. I'm going to 2 from multiplying the x times the right-hand polynomial, and 2 terms for multiplying the 2 times the right-hand polynomial. So what we get, well, let's do the multiplication by the x's first. X times x squared is just x to the third. X times minus 4x is minus 4x squared. That was what we did in the first part of lesson 3.4. And now we're going to take the 2 and we're going to multiply that times both terms. So 2 times x squared, that's a plus 2x squared. 2 times minus 4x is minus 8x. So there you go. Now this actually is not your final answer. This is a thing that can happen when you multiply polynomials by polynomials. Notice that in my first multiplication, I wound up with 4 terms. But these middle 2 terms are actually like each other in terms of like terms. So the x to the third has to stay put, but these middle 2 terms can combine because they're like terms. And this is why we looked at 3.3 adding polynomials before we actually started multiplying polynomials. Because when we multiply polynomials, oftentimes we have to add like terms on this middle step. So you end up, well, adding these like terms gives you a minus 2x squared. So you end up with a final answer of x to the third minus 2x squared minus 8x. Now, that works no matter how big, no matter how many terms these polynomials have. So you see in example 2, we have 2x minus 3 times x to the third plus 5x squared minus x plus 1. So what you would do is you take the 2x and you'd multiply it. Let me zoom in just a little bit more. There you go. So you'd take this 2x and you'd multiply it by all 4 terms of the right-hand polynomial. So take 2x times x to the third. you end up with 2x to the fourth. 2x times 5x squared, you end up with 10 times x to the third. 2x times minus x, you end up with minus 2x squared. And then 2x times 1 gives you a 2x. And then you go back, and after you've distributed that 2x into all four terms on the right, now you're going to distribute the minus 3 into all four terms on the right. Minus 3 times x to the third is minus 3x to the third. Minus 3 times 5x squared is minus 15x squared. Minus 3 times minus x gives you a plus 3x. And minus 3 times 1 gives you a minus 3. Now, once you've done that, we have some like terms here. Notice this 10x to the third and a minus 3x to the third can combine. That'll combine to give you 7x to the third. The 2x to the fourth doesn't have anything to combine with, so you just get 2x to the fourth. This minus 2x squared and a minus 15x squared will combine to give you minus 17x squared. 2x and 3x combine to give you 5x. And then this minus 3 is the only constant we have. So when you combine like terms, that's kind of a bad ink, but that's what the book does. It gives you 2x to the fourth plus 7x to the third minus 17x squared plus 5x minus 3. You can see example 3 does that exact same process. 3x squared times all three terms on the right gives you 3x to the fourth. When you multiply 3x squared times x squared, you get 3x to the fourth. 3x squared times minus 2x gives you minus 6x to the third. 3x squared times 5 gives you 15x squared. Then you go with your 4x here. 4x distributes into the x squared. You get 4x to the third. 4x times negative 2x gives you minus 8x squared. 4x times plus 5 gives you a plus 20x. 3x to the fourth, nothing to combine there. The minus 6x to the third and the plus 4x to the third can combine and give you minus 2x to the third. The 15x squared and the minus 8x squared can combine to give you 7x squared. And then the 20x is all by itself. So that's how you multiply polynomials times polynomials. By the way, let's scroll down here. If, I'm not going to work this out, but if you happened to be multiplying a trinomial times another trinomial, well, the same principle would work here. All you would have to do, whoops, let me go here, is you'd have to multiply x squared times all three terms of the second polynomial. Then you'd have to take 3x and multiply times all three terms of the second polynomial. And then you'd have to distribute the 7 into all three terms of the second polynomial. By the way, that would give you, well, 3 terms when you distribute the x squared, 3 terms when you distribute the 3x, and 3 terms when you distribute the 7. That would give you 9 terms to deal with. And then obviously some of them will probably be like terms that you can combine, and so on and so forth. Now, I'm not going to do that one by hand because it would take a little bit of time. But you do have a lot of practice problems in the cooperative group problems on 3-4B on the next page. So in other words, on page 50, look at those cooperative group problems. Now, as you look at those cooperative group problems, you can see that some of them are going to end up with lots of terms like this. There's a lot of terms there. Some of them, not so many terms. Some of them have multiple variables. Most of them will have one variable. But there you go. So here's what I'd like you to do. At this point, I want you to push pause on the video and do all 5 of these problems. And then when you come back, I will go over all of these problems. All right. So hopefully you went ahead and did that. First problem, 2x plus 5 times 4x squared minus 3x plus 1. So let's distribute this 2x into all 3 terms here. That's going to give you 8x to the third minus 6x squared plus 2x. And then when you distribute the 5, you get plus 20x squared minus 15x plus 5. So those are the terms. Again, notice that we had 2 terms by 3 terms, and we ended up with 6 terms at this stage before we combined like terms. So now let's go ahead and combine like terms. The 8x to the third, there's no other x to the thirds around. The minus 6x squared and the plus 20x squared combine to give you plus 14x squared. Plus 2x minus 15 can combine to give you minus 13x. And then that plus 5 is all by itself. So that is your final answer. So this polynomial here is the final answer to problem number 1. All right, we've simplified it and up to a point where there's no like terms to combine. All right. All right, let's go to problem number 2 here. Well, this one we start getting into lots of terms, but that's not a problem, really. We go x squared, that's going to distribute into all 4 terms on the right-hand side. So x squared times 2x to the third is 2x to the fifth. X squared times 3x squared is a plus 3x to the fourth. X squared times x is a plus x to the third. And then x squared times 6 is a plus 6x squared. So those are the 4 terms you get when you distribute the x squared into the right-hand polynomial. Now we're going to distribute this minus 9 into the right-hand polynomial. You end up with minus 18x to the third minus 27x squared minus 9x and minus 60, excuse me, minus 54. So there we go. Now we can combine like terms. By the way, some people, when they combine like terms, will do something like this. They'll take and put these on separate lines, and then order this so that the x to the thirds and the x squareds are sort of on top of each other. Sometimes when you get lots and lots of terms, it's easier to add up. It's easier to combine like terms if you write it this way. The traditional method is to write it in one single line, but again, this sometimes helps people. Now, the one thing you just can't get confused, you can't think that this expression is somehow different than this. This is all one big, gigantic expression. All right, you have to understand that. But if you do that, sometimes it makes it a little bit easier to combine like terms. So my final answer is going to be 2x to the fifth plus 3x to the fourth minus 17x to the third minus, looks like 21x squared minus 9x minus 54. All right, and that's my final answer to problem number 2. This answer right here. That's as simplified as we can get that when we multiply it out. All right, question number 3. This one I am going to utilize that little trick. I think that's a nice trick, especially when we have lots and lots of terms. So I'm going to multiply the x times each of these 6 terms. Again, that's a lot of multiplication, but that's okay. X times x to the fifth is x to the sixth. X times 2x to the fourth is a plus 2x to the fifth. X times minus 7 x to the third is a minus 7 x to the fourth. X times 3x squared is a plus 3x to the third. X times x is just x squared, so plus x squared. X times minus 8 is minus 8x. So those are the 6 terms you get when you distribute the x in. Now let's distribute this minus 1. Again, this is what I'm going to do. If you distribute the minus 1 times x to the fifth is minus 1x to the fifth. Notice how I indented that, so I'm writing that right below the other x to the fifth term. Minus 1 times 2x to the fourth is a minus 2x to the fourth. Minus 1 times minus 7x to the third is a plus 7x to the third. Minus 1 times 3x squared is minus 3x squared. And then minus 1 times x is minus 1x. And then I have one more multiplication to go. Minus 1 times a negative 8 is a plus 8. Okay, so hopefully that all makes sense. When you combine like terms, remember these 2 lines are not 2 different expressions. They're the same expression. I just kind of snaked it around onto the second line. So when you combine like terms, you end up with x to the sixth plus 1x to the fifth minus 9x to the fourth plus 10x to the third minus 2x squared minus 9x plus 8. So that's a lot of terms there. Again, as you can see, the bigger the polynomials that you're multiplying, the more terms you're going to get, especially in this first iteration of multiplication, especially before you combine like terms. Again, hopefully I've done all my calculations correctly. Now, again, if you want this 1 as a coefficient, doesn't matter if you write 1x to the fifth or just x to the fifth. That's fine. It's always okay to omit a 1 as a coefficient. Now, problem number 4, well, it's going to have a lot less terms. We just have a binomial times a binomial. So the first thing we're going to do is take a times a and get a squared. Then I'm going to take a times minus 7. You get minus 7a. So that's what you get when you distribute the a into both over here. When you distribute the 1 into both terms of the second polynomial, you get a plus 1a minus 7. Now you can combine like terms. You get a squared minus 6a minus 7. By the way, this binomial times binomial is something that you may have seen before, and you may have seen in your earlier classes, people say FOIL, F-O-I-L. And that actually is just an acronym for what these terms are doing. So let me explain what I mean by that. So you might have seen the word FOIL, F-O-I-L. I don't like memorizing this terminology because it only applies to binomial times binomial, but I did want to bring it up because some of you have undoubtedly seen this before. And what the F stands for is first, and it just basically means that the first term in this polynomial times the first term in this polynomial have to multiply. The O stands for outside. By outside, they mean the outside term of this polynomial times the outside term of that polynomial. The I here, let me write that. No, I don't want to write that. Let me use a little bit darker lettering. That's a little bit better. The I stands for inside, and that's what you get when you take the inside term of this polynomial. By inside, we mean closer to the middle, and the inside term of this polynomial. So 1 times a gave us the inside terms for I. And then L stands for last. It's the last term of this polynomial, the 1, times the last term of this polynomial, then minus 7. Again, I don't like to memorize that because if you try to memorize that with a problem like, for instance, 3, there's just too many multiplications going on. So what I like to do is I like to think of every time I do polynomial multiplication, I just take each term in the left-hand side polynomial and I multiply it and distribute it in and multiply times each term on the right-hand side polynomial. So there we go. By the way, after you combine like terms, a squared minus 6a minus 7 is in fact your final answer. Now the last problem here, problem number 5, let me scroll down. Similar idea, although this has multiple variables, it's the concept is the same. Z squared times a squared z gives you a squared, and then z is going to be raised to the third power, right? Z squared times z is z to the third. Z squared times a minus a z to the third is going to be minus a z to the fifth. Z squared times z is going to be a plus z to the third. Then we're going to multiply 3 times all 3 terms on the right polynomial. So you end up with plus 3a squared z. Oops. 3 gets multiplied by a minus a z to the third. So you go minus 3a z to the third power. And then 3 is going to get multiplied times the z. So plus 3z. Now in this case, now I would go and look for like terms, but it turns out there's no like terms. For instance, this first term here, we have an a squared and a z to the third. Well, I have a z to the third on this term, but not an a squared, so that's not alike. I have an a squared, but not a z to the third, so that's not alike. I have a z to the third, but not an a squared, so that's not alike. So you see that z to the third, a squared, z to the third, excuse me, a squared, z to the third isn't alike with any of these other terms. And you can go down the line. A, z to the fifth, well, there's nothing that has a z to the fifth on it. Z to the third, well, there's things with z to the thirds, but they also have a's on them. So that's not going to work. That's not going to combine. A squared z, well, again, there's things with z's on them. There's things with, well, there's things with a squared, but nothing in combinations. So we have 6 terms here, and none of them are alike. And therefore, there's nothing to combine. So this here is my final answer. No like terms going on down there. So that is what multiplying polynomials times polynomials is all about. And obviously we did binomials times bigger polynomials or binomials times binomials. But you can imagine if you had, 4 terms in your first polynomial and 7 terms in your second polynomial, how many multiplications you'd have to do. That would be a lot of multiplications. So obviously we're not going to ask you that on the test. We're probably going to ask you things like binomial times binomial, or maybe a binomial times a trinomial, or a binomial times, a polynomial with 4 terms, but not something gigantic. All right, so that is how we multiply polynomials times polynomials of any size. And obviously you can do those at-home practice problems if you'd like. Those are great practice for the test.